moving the scissor lift into position, and removing the terminal from the top of the bushing. Wearing a safety harness, position a scissor lift vehicle just to the edge of the metal floor covering in front of the bushing, so that all of the weight of the lift is on the cement floor. Using the handles located on the upper railing of the platform, extend the working platform towards the bushing so that there is a safe and comfortable working distance between the porcelain on the bushing and the platform. Attach the hook of the lanyard on the safety harness to the anchor point on the main railing before stepping onto the extension platform. Check again to ensure that the scissor lift vehicle is positioned between the metal floor and the yellow line on the concrete floor. The front wheels of the vehicle should not be touching the metal floor. Using the control panel mounted on the railing, begin raising the working platform.
He's raising the skyjack now. He's going to
Raise the platform to a position where it will be safe and comfortable to work at the level of the bushing where the terminal is located. Using the appropriate size ratchet wrench, begin loosening the bolts at the base of the terminal that secure it to the oil reservoir tank. When all the bolts are loosened, manually remove both the bolts and the washers, then set them aside for future use. Lift the terminal off of the top of the bushing and set it on the surface of the working platform. The draw lead conductor from the transformer extends through the center of the bushing inside the conductor core to make contact with the terminal at the top of the bushing. Lifting the bushing out of the service well, moving it north toward the scrap oil tank. While on the working platform of the scissor lift, use an open-face wrench, in this case 3/8 inches, to loosen the plug on the top of the oil reservoir tank, situated at the top of the bushing. The plug lies within a notch in the neck of the metal collar, under the flange attached to the conductor core. Once loosened, manually remove it and safely store it for future use. The plug is for an outlet that can be used in several different ways depending on the circumstances. In this case, it must be removed to replace the volume of air that the oil will displace when the bushing is drained. Over time, the gasket at the bottom of the plug will break down in the presence of oil and higher temperatures. Use a screwdriver as needed to clean away and remove any pieces of the old gasket that remain at the base of the threads. Choke one sling around the bushing above the first shed and below the oil reservoir by looping one end of the sling through the opposite end, and then tightening it to choke the bushing.
probably only about 200 to 300 pounds of pressure on that sling.
Choke a second sling on top of the first sling and tighten so that the free end is positioned exactly opposite the free end of the first sling. Raise the platform of the skyjack. Arrange the two loose ends so that they are resting on top of the oil reservoir. Request that the hoist hook be lowered, and then loop both loose ends of the slings into the hook.
I'll snug it up a little bit first, and then we'll decide whether we...
The crane operator should slowly remove any slack in the slings and raise the bushing for the sole purpose of determining whether there will be an even distribution of weight when fully lifted. If the bushing tilts when lifted slightly, adjust the position of the slings accordingly to ensure an even distribution of weight.
Pretty good there, Lloyd.
When the bushing is lifted just barely off the ground and it remains straight without shifting, the slings are in proper alignment.
Just barely touching the floor right now.
Prior to lifting the bushing, remove the scissor lift from the area and ensure that there are 2 team members at the base of the bushing. As the bushing is lifted, 1 team member should guide the unit as it rises to prevent any contact of the lower porcelain with the sides of the service well.
Yep.
Slowly lift the bushing straight up until the bottom is approximately 1 foot above the floor.
Okay, I'm clear there? Yep. All right. Okay, we're going to start heading north.
And slowly begin moving it to the north a few feet and then stopping. As soon as possible, the other team members should put the cover back on the service well. Begin moving the bushing northbound again toward the blue scrap oil storage tank. Both team members should gently guide the moving bushing with both hands on the flange or the ground sleeve below it.
Okay, going north.
Move the bushing to within approximately 2 feet of the scrap oil storage tank. Stop the movement.
Right there. Okay, now I'm going to put it down on the ground. We'll get a sheet of plywood.
Before lowering the bushing to the floor, place a piece of plywood directly underneath it to protect any damage to the lower metal flange on the bottom. Just before lowering the bushing, ensure that the drain valve, located on the flange on the opposite side of the capacitance tap, is on the side closest to the scrap oil tank. This may require that the bushing be rotated prior to it being lowered onto the plywood. Draining the oil from the upper part of the bushing and taking an oil sample for analysis. The tank used to store scrap oil is located at the north end of the bushing shop and has a large circular opening at the top of the tank into which scrap oil from the bushing will be drained. Using the appropriate size socket wrench, loosen the nuts that hold the cover to the oil sample valve in place. Once loose, manually remove them and store in a safe place for future use. Loosen the cap manually to reduce the amount of adhesion due to the amount of debris mixed with oil that has hardened over the bushing while it was in service. Place an oil-absorbent cloth beneath the valve before removing the cover to absorb any oil that may flow out when the cap is removed. Unscrew the remaining loosened bolts by hand and remove the cap so that the valve is now accessible. In this case, the valve is a quick connect type, similar to one used in a compressed air line.
Yeah. Now this is one of those things where, actually now you can see the connection there. It's just like a quick connect for an airline.
One end of the hose used to drain the oil will be inserted into the scrap oil tank, such that it just remains resting on the side of the opening. The other end of the hose is equipped with a connector that will snap into the quick connect fitting on the flange. When the connection has been made, check to see if there is oil flow inside the hose.
So if it doesn't fit, you have different...
Yeah, we're good.
It's gotta fit,
Yeah, now you can see the oil flowing out if you want.
If the oil is flowing out at a steady rate, check on the integrity of the connection by pulling back on the hose. The oil will drain into the tank while it remains upright, supported by the slings and resting on the plywood support at the bottom.
Look from this end and then down. And just follow it down to the other end. That's good.
While wearing appropriate gloves and using a plastic sample bottle equipped with a length of clear plastic tubing, withdraw a sample of the oil as it flows into the scrap oil tank. Depress the bottom of the plastic bottle while simultaneously immersing the end of the plastic tubing into the stream of oil draining out of the hose. By letting the bottle expand, the oil will be pulled through the tubing and into the bottle. Draw off enough oil to nearly fill the plastic sample bottle. Transfer the oil to a clear glass vial that has been wrapped with tape so that it can be labeled. Fill the vial to the top before screwing the top on.
And that's it. So now I'm just going to take this cap, we're going to seal it.
Just leave it there. Leave it there.
Okay. And that's our oil sample for this bushing.
Using a permanent marker, write the serial number of the bushing on the tape wrapped around the vial. Normally, oil is only tested for PCBs. However, if there was a problem during the initial electrical testing, a test for moisture content may also be requested.
189,
1,
58,
8, 9,
58.
5, 8. And that's it. Now that
Just like that. Hold it real still there. And just rotate it. Yep. Good.
Check to see if the oil has fully drained from the top half of the bushing by inspecting the end of the hose.
And go ahead.
When the flow has stopped, disconnect the hose from the bushing and lay some absorbent towels under the quick connect valve to prevent any residual oil from accumulating.
right.
Attaching the retainer plate to the flange to support the lower porcelain after the compression system is removed. After the oil in the top half of the bushing has been drained and a sample has been taken for testing, the bushing can be raised up off the block of wood on the floor and moved south above the metal flooring to a point above the service well where it will next be stationed upright. The purpose of the retainer plate is to hold in place the bottom flange of the conductor core below the lower porcelain. During normal operation, all the parts of the bushing are held together by downward pressure exerted by the compression system at the top. During refurbishment, the pressure mechanism is temporarily removed for servicing, and the retainer plate is required to keep the bottom half of the bushing attached. Unscrew and remove the large nuts and washers on each of the 3 rods that are attached to the bottom plate. Slide the retainer plate under the bushing, being careful not to chip the porcelain on the lower half. Adjust the position of the plate so that the holes on the flange are directly aligned with the rods attached to the plate, and that the rods are spaced evenly. Begin lowering the bushing so that the rods penetrate the holes that were previously aligned. Lower the bushing so that the bottom flange of the bushing rests on the retainer plate. Gather the 3 nuts and washers that were previously removed, and then place a washer on each rod that extends through the flange. Hand tighten a nut to each rod after the washers have been applied. Using an adjustable wrench, tighten each nut so that the plate below is firmly attached and supports the small flange at the bottom of the bushing. Replacing the bushing into the service well after the retainer plate has been attached to the flange. Notches have been cut out around the perimeter of the well so that the rods rising from the bottom will not interfere with how the bushing is seated.
Okay, I'm taking it east.
Slowly raise the bushing off the ground and move it eastward until it is almost at the edge of the designated well.
Okay.
When the bushing has stopped, a team member should remove the cover on the well
gonna continue
and store
east.
it in the appropriate area away from the designated work area. Resume moving the bushing eastward until it is directly over the opening of the well.
Take it down. And we're just going to line up those rods with those notches in the floor.
With a team member on either side of the bushing, align the position of the rods on the retainer plate with the position of notches around the perimeter of the service well. With both team members guiding it, lower the bushing down into the well, avoiding any contact with the edges of the metal floor. The width of the notches around the perimeter of the bay may differ, because other types of bushings may use rods of a different thickness.
Okay.
For this reason, it is important to ensure alignment with the appropriate set
There
of
you are.
notches as the bushing is descending.
Okay.
After the bushing is seated correctly in the service well, use the rolling warehouse ladder equipped with handrails and with the locking mechanism activated to remove both slings that were used to raise the bushing with the crane. Various shots of a GE bushing taken for reference purposes. Not part of this bushing service process, but are used to highlight physical differences in construction. Removing the oil reservoir tank from the upper part of the bushing. In order to remove the oil reservoir tank at the top of the bushing, the proper set of tools should be ready and available for easy access. They include a chain wrench, shown on the left, as well as a combination wrench that is open-ended at one end and has a ratchet on the other end. 2 hex keys that fit the ratchet will also be required. A couple of sets of Allen keys of various sizes are also recommended. On the top of the oil reservoir, a round flange approximately 6 inches in diameter and 1 inch thick is screwed into the metal conductor core that penetrates the entire length of the bushing. The flange acts as a portal through which the draw lead from the transformer can pass through the oil reservoir tank and make contact with the terminal at the top. Torque the flange using the chain wrench in a counterclockwise direction to loosen it. Once loosened, begin to manually unscrew it using both hands. Once removed, notice the O-ring at the top of the threads on the underside of the flange. All of the gaskets and seals will be replaced as part of the refurbishment process. Underneath the flange lies a metal collar surrounding the metal conductor core below the flange. The purpose of the collar is to firmly hold in place a black O-ring seal that prevents oil from leaking out from around the conductor core above the oil reservoir. Using the appropriate size Allen key, remove all of the screws on the surface of the collar. Also, be aware of the fact that there is a metal washer for each screw, and they must also be removed. When the washer is retrieved, place it over the screw to ensure it doesn't get misplaced. When all of the screws are removed, lift the collar off the surface of the oil reservoir, and then remove the black O-ring that surrounds the conductor core. Place all the screws, with the washers attached, back into the collar that was removed, and set it aside together with the gasket until it's time to reassemble the bushing. At the base of the oil reservoir, there are a series of headless hexagonal grub screws that are used to attach the reservoir to a collar that surrounds the bushing at the top. These screws must be removed using the ratchet end of the combination wrench. Insert the hex key into the ratchet, and then, by keeping a finger on the key, insert the male end of the key into the grub screw and unscrew until there is enough of the screw exposed so that it can be removed manually. Repeat this process for every screw until they have all been removed, leaving the oil reservoir resting on the collar surrounding the bushing. Return to the top of the reservoir and insert 2 externally and internally threaded inserts in opposing holes 180 degrees apart and that were previously used to secure the terminal to the reservoir tank. Into each insert, screw an appropriately sized eye bolt strong enough to support the weight of the reservoir after it has been suspended. Loop one end of a sling designed for a specific working load limit to a metal shackle, and then connect the shackle to the eye bolt by screwing a threaded connector bolt through the eye bolt while connecting both ends of the shackle. Repeat this process for the opposite eye bolt.
Yeah, so I'm just gonna, when he's ready, I'm gonna lower the hook down.
Okay.
And
Lift it off.
and we're gonna lift the can right off and just bring it across, and we're gonna lower it down right here.
And then signal to the crane operator to lower the crane hook closer to the hitching point above the reservoir. Hitch the sling to the hoist hook only after it is within a comfortable reach, and then hand signal to the crane operator to begin lifting the reservoir tank.
Okay, we're going up.
As the tank is lifted, the team member on the scissor lift should use both hands to help guide it off the conductor core.
It's a very tight fit. Be very careful, there's oil in that can still.
It is important to minimize any sway or tilt in the upward motion, as there is still approximately 1 inch of oil around the outside edge of the reservoir tank on the inside.
There's about 1 inch of oil around the outside edge of that can on the inside. So if we slosh it at all, it's going to come splashing down on us.
Reducing the pressure exerted by the compression system and the removal of the large brass nut or collar. The purpose of the compression system is to keep all the parts of the bushing tightly compressed and held securely together as a single unit. Place the appropriate size washer on each bolt and then hand tighten a nut over the washer. In normal operation, the springs exert a force on the plate above them. The springs exert a force on the plate above them that pushes against the brass nut that is threaded to the conductor core. This causes a downward pressure between the brass nut at the top of the bushing and the flange on the conductor core at the very bottom of the bushing. In order to remove the brass nut from the top of the conductor core, it is necessary to back off the pressure exerted on it by the springs in the compression system that push up against it. A series of threaded bolts that extend through the plate above each spring make it possible to adjust this pressure. When all of the nuts have been hand tightened, use a hex ring spanner wrench to tighten them further to ease the pressure off the large brass nut on the core so that it can begin to turn counterclockwise. Tightening the nuts about 1/8 of an inch using the wrench is usually enough to allow the large brass nut to turn. This is equivalent to approximately a 200 to 300 pound pressure reduction. The total downward pressure exerted by the springs in the compression system is approximately 3,000 to 3,500 pounds. Using an adjustable pin wrench that grips the brass nut in 2 holes bored into the top surface, torque the nut loose. Before manually unscrewing the nut, it may be necessary to remove any oil residue on the nut by using a sheet of oil-absorbent material. Unscrew the nut using both hands to turn it counterclockwise.
Okay. He's actually tightened up those springs more. That's how we got the pressure off of the brass nut, right? Right. And now we're going to leave that pressure, that extra pressure, that added pressure that we put on those springs.
You're going to leave it on?
We're going to leave it on so that when we put it back together,
That makes sense.
we've got even a little bit more.
You can just lift it off.
When the nut reaches the top of the threads on the conductor core, detach the gasket that may have adhered to the underside of the nut and let it fall onto the plate on top of the compression system directly below.
Got extra compression, so when we put the nut back on, when we put this all back together and put the nut back on, we snug up the nut to the springs, then we release the pressure on the springs and they start pulling again.
Slide the nut up and off the conductor core using both hands, and then remove the oil-soaked gasket after the nut has been completely removed. Removal of the compression system from the bushing. To remove the compression system from the bushing, choose 2 of the threaded bolts that are 180 degrees opposite from each other, and onto each bolt, attach a large threaded galvanized eye nut that screws onto each threaded bolt. The eye nut must be strong enough to support the weight of the compression system after it has been suspended. Loop one end of a sling designed for a specific working load limit to a metal shackle, and then connect the shackle to the eye nut by screwing a threaded connector bolt through the eye nut while connecting both ends of the shackle. Repeat this process for the opposite eye nut using the other end of the same sling. and then signal to the crane operator to lower the hoist hook closer to the hitching point above the compression system. Hitch the sling to the hoist hook only after it is within a comfortable reach. In order to free the compression system from adhesion to the gasket that it is seated on, it will be necessary to heat the bottom plate using an acetylene torch. For this process, it is imperative to wear a half-face air purifying respirator with the appropriate gas vapor cartridges, as well as safety glasses. Using the acetylene torch, heat the area at the base of the springs and around the outside of the bottom plate. When the system is free from adhesion, hand signal to the crane operator to begin raising the compression system. As the system is lifted, the team member on the scissor lift should use both hands to help guide it up off the conductor core. When the compression system is off the core, the crane operator can then move the system north and lower it onto a workbench for refurbishment to begin. The area on the workbench should be covered with sheets of oil-absorbent material before it touches down, with the help of a team member guiding it into position. Once it is resting on the bench, remove the sling from the hoist hook. Removal of the upper porcelain insulator from the bushing. Choke one 24-foot sling around the porcelain between the third and fourth shed, and choke another 24-foot sling around the porcelain between the second and third shed. Following the same safety protocol as when removing the terminal, raise the working platform of a scissor lift vehicle to the level of the hoist hook and attach the ends of the slings to the hook. Due to the fact that the choking points are different, each sling will be a different length in relation to the distance from the hoist hook. This could cause the porcelain unit to tilt when lifted and thereby become unsafe. To compensate for the difference in length, a large shackle will be connected to the sling that is shorter. Remove the shorter sling from the hook and attach a large shackle to the loop on the end. Reconnect the sling to the hook using the attached shackle. Signal to the crane operator to raise the hoist hook to eliminate any slack in the slings. Lower the working platform of the scissor lift to a safe and comfortable working position at the level of the top sheds on the porcelain. Wrap a cord of the appropriate size and strength separately around each sling between the two top sheds on the porcelain.
How's that looking?
Re-wrap the cord around each sling several times to reduce the possibility of slippage while it is being hoisted. With the aid of a second team member using the rolling warehouse ladder with handrails and with the locking mechanism activated, begin tying both slings together tightly with the cord. Make sure the knots are as secure as possible. To enhance the security on the slings during the hoisting of the porcelain, loosely attach a security belt around the porcelain and over both slings between the third and fourth sheds from the top.
Just a little bit.
In order to prevent the porcelain from being chipped while being lifted, insert a rubber pad directly under the metal security buckle before it is tightened.
You really can't go too tight on that.
Actually, you can. You'd be surprised how tight you can go.
Tighten the buckle as much as necessary to prevent any slack in the vertical slings.
Okay. You're good with
The porcelain on the top half of the bushing is seated on a gasket that rests on the top crown of the metal flange. The gasket provides a seal by preventing the oil inside the bushing from escaping. It also protects the porcelain from chipping or cracking while seated on the crown of the flange. Begin removing as much of the hardened gasket material as possible using an appropriate scraper. Over time and with exposure to the elements in nature, the gasket hardens, making it very difficult to separate the porcelain from the flange. Wearing a half-face air purifier respirator with the appropriate gas vapor cartridges, as well as safety glasses, heat the area around and under the flange where it meets the porcelain. Depending on the amount of adhesion, it may take longer using the torch to loosen the bonds that have been formed. By raising the hoist in very small increments, the crane operator can eventually lift the upper porcelain unit away from the flange. With the porcelain suspended just above the flange and before raising the unit all the way off, the bushing team can assess the arrangement for safety, security, and balance. Using the rolling warehouse ladder with handrails and with the locking mechanism activated, a team member should tape a soft oil-absorbent cloth over the opening of the conductor core prior to the porcelain being lifted over top of it. Since the measuring tolerance for the parts that slide over the conductor core are very small, The end of the core needs to be protected from any kind of damage.
Yep. Okay. Ready, guys? We're going to make the lift. Oil level's good. Yep. Okay. Just keep an eye on the top there. Okay. There's some loose paper.
The crane operator can now begin to lift the porcelain off the flange as it is being guided by the team member on the rolling ladder. In some cases, the outer layer of paper may fall off during the lift, but this is nothing to be concerned about.
I will go east, possibly even a little bit north, I think. I am? Okay. Hang on a second. We're free. Okay. Going up again. That's actually the paper. That's the paper already starting to uncoil. It's a very small amount. We're not too concerned with that. Yes, that's what it's all about right now. Okay, I'm just about to clear the core. Nope. Okay, I'm going to bring it down.
When the conductor core is cleared, the covering on the top of the conductor core can be removed. The bushing can then be slowly moved southbound and lowered onto a section of oil-absorbing material placed over the metal flooring where the service wells are located.
Yep. Okay, Graham, I'm going to bring it down now. There we go. Perfect. Yeah, we'll leave those.
In order to be available to lift the conductor core after the porcelain has been lifted off, the large brass nut that was previously removed should be threaded back on. To avoid cross-threading the heavy nut, slowly lower it and gently place it on the threaded section of the conductor core. Turn it counterclockwise first until a subtle clunking sound is heard. This indicates that it is correctly seated on the top thread for clockwise rotation to proceed. The shackle on the end of the shortest sling can now be removed from the hoist hook and safely set aside. The longer sling can then be removed from the hook as well. Draining the oil from the lower part of the bushing. With the upper porcelain insulator removed, the large brass nut at the top of the conductor core will serve as a choke point when the bushing is lifted to drain the oil from the bottom half. To protect the threads on the conductor core during the lift, and also to protect the sling, a team member should wrap a single layer of oil-absorbent material around the core directly below the large copper nut. Using the rolling warehouse ladder with handrails and with the locking mechanism activated, loop the sling around the core over the top of the oil-absorbent material, and then tighten it before attaching it to the hoist hook. The team member should hold the sling against the conductor core and in line with one of the 3 rods that are holding the core retaining plate to the bottom of the bushing. The crane operator can then remove any slack in the line by raising the hoist. To collect the oil that will be drained from the bushing, roll a 45-gallon drum equipped with a mutual drain valve at the bottom and seated on a circular cart with wheels to the cement section of the floor. With the help of one team member guiding it with a hand on the flange, the crane operator can begin to slowly raise the bushing.
Okay, I'm gonna hang on, guys. I'm gonna come west. Get this out of your way.
When the bottom has cleared the top of the service well, immediately place the cover on top of the service well.
Okay. I'm gonna get it out of your way for a second, Lloyd.
When moving the bushing using a bridge crane, it may be necessary to relocate the position of the jib crane in order to lift the bottom end of the bushing when it comes time to empty the remaining oil from the lower end.
Okay. Now I'm gonna take it east again.
The crane operator can then move the bushing toward the 45-gallon drum.
That's pretty good right there, I think. Okay, so what I'm going to do, just like that.
The bushing can be lowered to the floor at a position approximately 10 feet north of where the 45-gallon drum is situated. Once on the ground, loop a sling around the smaller bottom flange that rests on the larger retaining plate at the base of the bushing. The sling should go inside the 3 rods that are attached to the retaining plate. Manually choke the sling to tighten it. The crane operator can begin to lower the tension on the hoist to tilt the bushing slightly toward the 45-gallon drum. Move the drum closer to the base of the bushing.
Okay, now it's gonna be messy.
Cover the floor on the east and west sides of the drum with sheets of oil-absorbent material so that spilled oil will be absorbed.
Have to do, because you're gonna, here, just run it parallel like this. Put this one over here like this.
Lay the sections of material north to south on either side of the drum, but not on the south side, which would prevent the drum from rolling to catch the oil.
Now what's going to happen is as we're tipping this thing down, oil will start coming out of here, okay? So what you have to do is keep moving this with it as the angle changes. Okay, and I'm going to start watching what I'm doing.
At this point, team members should prepare to roll the drum back away from the bushing as the angle changes and oil begins to flow out from between the flange and the main insulation. Other team members should help steady the bushing as it is tilted to prevent spillage. The crane operator can only tilt the bushing to the edge of the drum, and so in order to remove the remaining oil, the bottom of the bushing must be raised higher.
We're just reaching a point, we just want to get as much oil as we can out before we hook up the jib.
Okay.
That's about as far as we can go right there.
Just to the top of the oil.
That's it.
Re-choke the sling that was previously attached at the base of the bushing, and then attach the free end to the hoist hook on the jib crane. The jib crane operator can now begin to raise the jib crane hoist hook and remove the slack in the sling choked to the bottom of the bushing.
They're going to raise that end up.
You coordinate that.
Yeah, I'll watch whatever is happening there because the jib floats free,
Okay.
right? So, okay. Okay. You're good. And Lloyd is basically going to follow the oil coming out with the drum.
Yes.
Now he's going up, now I can go down.
As the bottom of the bushing rises, the remaining oil begins to flow out.
Oh, there's very little in there. There's half a drum maybe.
Oh, okay.
When the oil flow begins to subside and the bushing is horizontal, lower the top end to remove the remaining oil inside the lower portion.
Okay, just take it up a little bit more, Graham, and then I'll let it down a bit and we'll make sure that we have a good tip on it.
Removing the conductor core. The central core of the bushing consists of a metal inner conductor core that is surrounded by an outer metal core over which paper insulation is wound. Cardboard sleeves placed between the two cores are what determines the space between them. To begin the process of removing the inner conductor core, place a small bucket underneath the top of the outer core to collect the residual oil that may flow out from between the cores. The wire connecting both cores is designed to ensure that they both have the same electrical potential. During regular operation, the draw lead from the transformer travels the length of the inner conductor core, and so by making the potential the same for the outer core, accurate testing can be performed through the capacitance tap. Disconnect the wire by using an adjustable wrench to first loosen the nut holding the wire in place and then manually removing it with the washer. Begin to loosen the nut that lies beneath the lead, which controls the tension that holds the band around the inner core.
Take anything apart till later. Second.
Actually, yep.
Once loosened, manually loosen it further to make sure that the band can easily slide down the length of the inner core when it is time to be removed. Screw the nut and washer that held the lead wire in place back on the bolt, but loosely, simply to prevent them from being lost.
Now that's going to be loose enough just to slide off when we have to take it off. We'll just slide that right off of here. We're just, because it's accessible to us right now, this is why we're going to take care of it right now.
Support the conductor core retainer plate at the bottom of the bushing by resting it on stacked pieces of plywood.
I want to make sure that it's
Place the
weighted
long
more at the
cardboard
front,
sleeve
because,
at the
we're gonna
top
be
of the
pulling that
bushing
porcelain off
onto
as
the
well.
covered wooden support.
This porcelain we're going to be putting here, choker here, going up to the hook. We have to lift that off. We're going to have to lift that off as well down this way. So we should be okay. I'm going to swing exactly.
To remove the conductor core, the retainer plate must first be removed from the bottom of the bushing. Then the porcelain insulator must be lifted up just enough to take the weight off of the conductor core that passes through the center of it. Once the weight is off,
Looks good to me.
the core can then slide out the bottom end. 2 slings must be choked at each end of the porcelain and then attached to the hoist hook so that it can be raised up and supported. There must also be enough space at the bottom end of the bushing so that the conductor core will clear the bottom of the porcelain insulator completely. When the bottom end of the bushing is raised, the top end will need to be supported. For this purpose, a wooden support frame that has been covered with a sheet of oil-absorbent material will be used. Begin removing the bottom conductor core retainer plate by first holding a piece of plywood between the porcelain and a metal rod that runs lengthwise along the top. The plywood serves to protect the porcelain below from the rod above when the rod is removed. Keep the plywood in place for the time it takes a team member to loosen the large nut at the other end using an adjustable wrench. Once the bolt has been unfastened, the rod can slide out the bottom end. Loosen the large nut for the rod running up the side of the porcelain and remove the nut at the top of the flange. For the rods that run up the side of the porcelain, the plywood is not necessary, because when the rod becomes unfastened, it will fall to the floor rather than on the insulator. When the retaining plate has been removed, the sling at the bottom can also be removed. Attach and choke a sling just above the top shed of the porcelain, and choke the other end of the same sling between the 3rd and 4th shed on the bottom half of the bushing.
Just gonna slide this portion off right here.
Remove the band on the inner core by sliding it gently all the way off the top of the core.
Yep. Okay.
Hook the middle section of the sling that is choked at both ends of the porcelain to the hoist hook after the crane operator has lowered it to just above where the bushing lies on the floor. Adjust the top choke as required by sliding it up the top of the porcelain to the appropriate position. The weight needs to be removed off the core evenly. Double-check the locations of where the sling is choked around the porcelain after the slack has been removed, and then lift the porcelain up just enough to remove the weight off the core.
Quite good like that. I'll even hold it for you. We'll wait until he starts smoking. Yeah, so I've already removed this.
In order to free the bottom flange on the conductor core from sticking to the porcelain, use an acetylene torch to heat up the bottom plate. It is imperative to wear a half-face air purifying respirator with the appropriate gas vapor cartridges, as well as safety glasses when using the torch.
Once we see some smoke coming from that flange, we'll know that the heat has made it through to the gasket, and then
Using the acetylene torch, heat the entire surface of the bottom flange. The first sign of smoke indicates that the heat has penetrated to the gasket on the other side of the flange. Continue heating using the torch until smoke has appeared, at which point it may be possible to separate the flange from the porcelain.
usually when you start seeing smoke coming from the gasket area, then you're okay.
At the appropriate time, a team member positioned at the top of the bushing should place a block of wood on the top of the core conductor and gently but firmly hit the wood with a rubber mallet to free the lower flange at the other end.
That was it. Right on the money.
When the flange is free from the porcelain, two team members can slide the entire length of the core out of the bushing, with hands placed on the metal sections of the core only. As the core is being extracted, one team member should remain at the bottom of the bushing to ensure that the top of the core does not fall to the floor. When completely removed, place wooden blocks under the metal sections at each end to support it. Do not rest the core on a cardboard insert. Removing the lower porcelain insulator from the bushing. Under normal operating conditions, all the parts of a bushing are held tightly together by downward pressure exerted by the compression system at the top. This downward pressure pushes on all the parts and squeezes them against the lower flange at the base of the bushing below the lower porcelain insulator. Over time, the gaskets and seals that lie between the various parts can harden, which can prevent the parts from being easily separated. In order to free the lower porcelain that lies directly under the ground sleeve, it will be necessary to use an acetylene torch and apply heat to the surface of the bottom rim around the ground sleeve. It is imperative that a half-face air purifying respirator with the appropriate gas vapor cartridges, as well as safety glasses, be worn while using the torch. During the heating process, the crane operator can place a stack of wooden blocks adjacent to the bottom end of the porcelain. Then, by slightly hoisting the porcelain, he can slide the stack of blocks directly under the end so that the porcelain rests on the block. As the heating continues, the crane operator can repeatedly raise and lower the porcelain to rest on the blocks. This process may be enough to break the seal where the heating is taking place.
There it goes. Okay, it just separated on the bottom.
In this case, when the operator lowers the load very briefly, it's enough pressure to break away the adhesion and the porcelain separates from the ground sleeve. Attach and choke a sling around the porcelain between the two lowest sheds at the bottom. With the help of two team members guiding the porcelain, the crane operator can slowly move the unit off of the bushing while being careful not to damage any of the brown insulation paper that has been exposed.
Okay, now I'm going to take it east.
You want to stand it up right there?
Yes.
Bring the unit to rest on top of sheets of oil-absorbent material that have been arranged on a section of the metal floor. Lower the hoist so that the sling choking the porcelain at both ends can be removed from the hoist hook, and attach the sling choking the very end of the porcelain to the hoist hook. Lower the hoist so that the sling choking the porcelain at both ends can be removed from the hoist hook, and attach the sling choking the very end of the porcelain to the hoist hook. Slowly hoist the attached sling so that the narrow bottom end of the porcelain section stands upright and the wider top end rests on a sheet of oil-absorbent material. Two team members should be present to gently lower the unit to the floor when it becomes upright. Temporary reinsertion of the conductor core back into the bushing. Concentric rings of brown oil-impregnated paper insulation wound around the outer core are revealed when the lower porcelain insulator is removed from the bushing. Together with the foil condenser layers that are uniformly placed during the winding process, this material is known as the main insulation for the bushing. The main insulation must not be exposed to air for more than 12 hours before the bushing is being rendered unusable. For this reason, it must be immersed in the oil bath before that amount of time. In order to lift the remaining portion of the bushing into the oil bath, it is necessary to reinsert the metal conductor so that it is again supported on the bottom by the lower flange, and also because the large brass nut that screws on at the top can be used as a lifting point to choke a sling around. Gently lift the top of the metal conductor core off the wooden support it is resting on, and carefully insert the top to the outer core at the bottom end of the bushing. Be aware that there are cardboard sleeves equally spaced along the length of the core. Each sleeve is about 6 inches in length, and all have a specific thickness designed to provide the correct amount of space between the conductor core being inserted and the outer core around which the paper insulation is wound. During insertion, carefully lift each sleeve inside the opening to the outer core so that it does not get damaged and maintains its required thickness. When the conductor core has been completely inserted, attach the large brass nut at the top by screwing it back onto the threads. It may be necessary to wipe away any debris that may have accumulated in the threads during the insertion process. When the nut is about 3/4 of the way to the end of the threaded section, wrap an oil-absorbent sheet around the threads below the nut before choking a sling around it. In this way, the threads are protected from any damage that could occur during the lift. Tighten the choke around the core and set the other end of the sling so that it rests on the core above the brass nut rather than on the floor. Removal of gaskets and seals from the capacitance testing port.
Now, there's actually a ring that locks the whole mechanism into the flange, but this actually comes apart. This entire thing comes apart in pieces. There's about there's the actual main probe, the pin, which is attached to a wire.
That goes down through the center core?
Goes down into the core.
Okay.
We have to actually remove this. This section right here is threaded. Right there, this brass ring right here it has a little locking screw in it. We have to unlock the screw, loosen off the screw, and then we can unscrew that portion there.
Great.
Okay? Then we can take this other locking ring, the big locking ring down below, it gets threaded out on those threads on the outside. Then you can remove this poly piece.
Yes.
The actual pin will stay with the bushing.
Okay.
Okay?
To remove the insert, a special cylindrical pin wrench is used. This tool is basically a round metal cylinder designed to fit a circular channel with specific dimensions. The insertion end has pins that extend out of the bottom that engage with the object to be loosened or removed. Insert the tool into the port and gently turn it until the pins on the wrench engage with the pins on the insert below it.
Got to make sure we're getting it right. I think it's in now. Yeah. So we're just going to take a rod.
Once engaged, insert a rod through the hole in the handle of the wrench, as this will provide a way to increase the amount of torque that can be applied. While pushing down in the wrench, begin loosening the insert at the bottom. Loosen the insert until the capacitance tap itself becomes loose and can move within the port.
And just check to see if it, yeah, you can see that they've moved, no problem, they're gone. Now we're going to see if we have a seal. It's still there. I'm going to open it up a bit more.
Over years of exposure to the elements outdoors, the oils and gaskets inside the port become hard, making it difficult to unscrew or remove the parts inside.
Okay, that should be good enough for now. Now we're going to try this same thing, glue and oh no. Yeah. We're going to need some heat.
In order to free the capacitance tap that is being held in place by the insert, it will be necessary to heat around the outside of the capacitance testing port using an acetylene torch.
There's a number of gaskets, little tiny rubber O-rings in there, actually nitrile O-rings, and they have to be replaced. They've been in there for 40 years as well. It's all the part of the gaskets and seals.
It is imperative to wear a half-face air purifying respirator with the appropriate gas vapor cartridges as well as safety glasses. After heating for an appropriate amount of time, Determine if the capacitance tap will begin to move.
Okay, let's give it a try.
Insert a wrench handle in the port and leverage it against the port wall to apply pressure on the tap.
There we go. That's good. No, now we're going to spin this around a bit. Graham, do you have your other pliers?
When the tap moves, look for a small locking screw located on the side of a brass collar that sits on top of the capacitance tap, above a red porcelain part with concentric rings. This is a locking screw that holds the brass collar tight against the capacitance tap. Loosen the screw without removing it. When the screw has been loosened, unscrew the collar and remove it from the capacitance tap.
Okay, that's all we're doing there. Okay, now we're going to unscrew that part there. Yeah, a little warm. There it goes. We've broken that. Now we can unscrew this thing here.
Beneath the collar and on top of the red porcelain part with concentric rings, there is a very small O-ring. Remove the O-ring from the capacitance tap and set it aside with the collar that was also removed.
It's very difficult to see, but right there, there's a small seal. Right there. See it right there? Just the tiniest of O-rings right there. There it is there, you can see it. Okay. Yeah, I'm going to lift that off. Okay. And there it is there.
Hold them real, put a hand down on something. Thank you.
Okay.
Yep.
Okay, you can keep those spare parts there. Now, we're going to remove that big ring. And it's coming up slowly, but
Reinsert the cylindrical pin wrench and engage the wrench with the holes in the top of the insert that will be removed. Continue turning the wrench until the insert is close to the top of the port.
okay.
Remove the wrench and place the tip of a small screwdriver in one of the holes on the top of the insert.
And there it is there.
Use the screwdriver to unscrew the insert and completely remove it from inside the port.
All right, Graham, there you go. And now we're going to,
Use your other hand, please.
oh, now we're going to extract this actual part. We're going to pull it off and leave this pin behind.
Pull upwards on the red porcelain part with concentric rings around it and remove it from the shaft of the capacitance tap. This part is symmetrical and has gaskets attached to both sides so that it will function either way it is oriented when it is put back in place.
All right.
Okay. And again, there's gaskets on both sides of that, right there and right there.
Hold it steady.
Is that symmetrical? Is there a,
It wasn't one time.
so you can put it in either way?
It will work either way.
Okay.
And that is the gasket at the bottom of the cap tap probe.
It has to come off.
It's made of nitrile.
What sits on top of it?
The
Ceramic?
ceramic or the porcelain part of the cap tap.
Okay, sits right on top.
Yeah.
See the
And that
back
has to
scissors?
come off, right?
That gasket's going to have to be replaced.
How are you going to do that?
Well, I'm going to extract that gasket and I'll make a new one and I'll slide it back over top of this probe.
Extracting it how?
just with some needle nose pliers. We'll reach in size or some tweezers.
See that come out?
If we need
Using needle nose pliers, extract the gasket and set it
Okay, there
aside
it is there.
so that an exact duplicate can be made of
Hold
it.
this light, James? Somebody?
I'm holding the unit in
Oh, I
place.
got you. Okay, give me that. Okay, good.
Submerging the exposed main insulation in oil. After the bushing has been disassembled completely, the exposed main insulation must be protected from air and submerged in oil until it is ready to be reassembled. Place a plywood board under the bottom flange of the conductor core at the bottom end of the bushing while it rests on the floor. With the sling that was choked just under the large brass nut at the other end, slowly begin to raise the top end of the bushing so that the bottom end remains resting on the wooden board.
Lloyd, I'm just wondering, this is a 20-foot tank. What's the length? What's the length from there?
Continue hoisting the bushing to an upright position, keeping in mind that the oil tank it will be submerged in is 20 feet deep. Continue to raise the bushing upright while placing oil-absorbent cloths on the floor where necessary to absorb any oil that may drip onto the floor. As it is being uprighted, a team member should slide the bottom of the bushing while it remains on the plywood board to a position directly under the top of the bushing by holding onto the flange above the ground sleeve. Ensure that the small flange at the bottom remains on the board as it glides across the floor. Continue hoisting the unit straight up, and as the bottom approaches the oil tank, a team member should begin to glide it over the top of the tank by holding on to the small flange on the bottom. Begin lowering the bushing into the tank with a team member standing at the side of the tank. As the bushing is slowly submerged in the tank, team members should ensure that the unit is centered and that as the large flange in the middle of the bushing enters the oil, there is enough space around the sides.
6 inches all the way around. Perfect. We're right dead center.
Team members should also ensure that the level of oil in the tank remains low enough so as not to overflow as the bushing is lowered. Lower the bushing until it sits on the bottom of the tank.
Hopefully the tank won't overflow. We filled it up on Saturday. We weren't really sure how much it was going to displace. No, we're good. It's the oil level's about here right now. The core starts getting smaller now, so it's not an issue. Yes. At least up to the paper. We have to have it submerged up to the paper, but we'll probably send it right in, let it sit on the bottom. Oh, we're doing well. The oil's still at about this level. It's good. The oil's right here. It's not coming up anymore because now we're getting smaller again. That's it. We're 6 inches shy.
Lower the hoist and carefully remove the sling from the hoist, leaving the other end choked around the large brass nut at the top of the bushing.
And then we don't have to worry about it anymore. She's fine right there. We are good.
Tie a cord through the loop in the end of the sling that was attached to the hook, and then secure it to the outside of the oil tank. This will prevent it from dropping into the oil tank.
Yeah, it worked perfectly.
We're tying
We're just tying off the sling so that it doesn't drop into the oil.
Okay.
That's, yeah.